Hi, Algebra 2 students. I hope that this distance learning phase has been going well for you. Today we're going to learn about 11.3 data distribution. It's our third section of our statistics unit. Before we get started, I just wanted to thank those of you who are watching the videos. I really appreciate that you are taking this time to further your education and really understand the content rather than just doing the bare minimum, doing the homework and calling it done. So I really appreciate you guys for watching these videos that I'm putting effort into creating for you. Alrighty, so we're going to get started on 11.3 data distribution. Our learning intentions for today, you're going to understand what the word skew means, and we're going to be able to analyze the distribution of data. So data distribution, what that means is it's a list of data showing all possible values and how often they occur. Another word for how often things occur is called frequency, so you might hear me use the word frequency. The data distribution helps us visually identify trends and measures of center. So an example of this, and I have this list of numbers highlighted on the right because we're going to use that for these first couple problems here. So an example of data distribution, it's a list of data, but we want to make sure that that data is organized in a manner that's actually beneficial to us. So I recommend we take this list of data that's just in a random order. Let's order it. That way we can kind of see the maximum value, the minimum value, the frequency of our numbers, and that kind of thing. So I'm going to start at our smallest number, which is -8. And then, let's see, the next number is -2, -1, 0, 1, 3. We have 2 4s, a 5, a 6, and a 9. So by ordering our number this way, it helps us see some trends. Now we can easily see that 4 is repeated, -8 is the smallest number, 9 is the biggest number. So those are just a couple benefits to actually ordering our data. The next vocab word you should already know, mean, is the average of your data. So mean is the average. To find the average, you add up all your numbers and then divide by how many numbers there are. So an example of that is adding up all of these. Oh man, I don't have my calculator up. I apologize. I took a lunch break before I made this video. So I turned off my computer, my calculator went away. Okay, so if we want to find the mean of this set of data, let's make this calculator smaller so we can actually see our data set here. Okay, so if we want to find the mean of our data set, we are going to type in these numbers, so -8 plus -2 plus -1 plus 0 plus 1. Hold on. I messed up. Sorry, let's try again. -8 plus -2 plus -1 plus 0 plus 1 plus 3 plus 4 plus 4 plus 5 plus 6 plus 9. We get 21, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. So I'm going to divide by 11. My mean of this data, when I add up all my numbers and divide by 11, I got 1.91. Oh, I'm still a highlighter, so I'm going to write 1.91. So I added up all those numbers and divided by 11. You can see my work on my calculator, so I'm not going to write it on our screen. Median is the middle number. So median, you put all of your numbers in order. So that's why I did that on the data distribution section. And then to find the median, you want to find the number in the middle. So just cross out the bottom and the top number again and again and again until you end up in the middle. So our middle number here is 3. Our median is 3. I'm actually going to go back and erase all of those just so we can still see our numbers, but you get the idea there. So our middle number is 3. Mode, the number that occurs the most. Right here, we've already talked about it a couple times. Ooh, I thought I clicked on a highlighter. 4 and 4, right? So our mode is 4. Range is the maximum number minus the minimum number. So here we have our maximum of 9 minus our minimum number, which is -8. So there are 17 numbers in between our max and our min. Our range is 17. Okay, so those are all the examples where we're going to be using those data sets. The next couple things are just good for you to know. I guess the last couple will also be using it. Okay, so normal distribution. A normal distribution is a symmetric distribution where your mean, your median, and your mode are all exactly the same. And it's a bell-shaped curve. So bell-shaped curve means it looks like this. It's a symmetric curve. Excuse my drawings. You guys know I'm terrible at drawing. But that's what a normal distribution looks like. A skewed distribution, the mean is to the left or the right of the median. So skewed means it's not symmetric. It's like there's way more data on one side versus the other side. So those are examples of skewed distribution and normal distribution. Standard deviation. If you guys take statistics, this is a concept that comes up a ton in statistics. It's the measure of how spread out the data is. If it's a large number, your data is very spread apart. If it's a small number, your data is very close together. It tells you how far away from the mean your data is. So if your standard deviation is 3, that means you're 3 away from the mean. If you're a smaller number like 0.2, that means you're very, very, very close to the mean. First quartile is the median of the first half of numbers of your data set. So when you're looking at your data set, we've already decided here that 3 was the middle number, right? 3 is our middle number. So if we want to look at our first quartile, our Q1 is what it's sometimes called. Our first quartile, we're going to only look at the first half of our data. And then we're going to find the median of that. So we're going to cross out the smallest and the biggest numbers until we get to the middle. So our first quartile here is -1. Same idea with third quartile. You're just going to look at the last half of your data. So 4, 4, 5, 6, 9. And then cross out smallest to biggest until we get our answer of 5. All right, 5-number summary. This is what you use to actually draw yourself a graph that we call a box and whisker plot, or a box plot is sometimes what it's called. But your 5-number summary includes the minimum, which we've already found, right? The minimum here was -8. Your first quartile, which again we've already found. Your median, which we've already found. Middle number, already highlighted. Third quartile, again we've already found. Maximum, which we've already found. So your 5-number summary is information that you need to draw a box plot, but it's typically information that you already needed in order to answer questions about your data. So if you have an older calculator, the reason that I'm specifying that it's written in this order is for older calculators, you do get your answers given to you with a comma, and you have to know what each of those values actually represent. So our minimum here is that -8 from above. Our first quartile is right here, that -1. Our median, what was our median? Our median was 3. Our third quartile is 5, and our max is 9. So those 5 numbers are a summary of the 11 numbers from above, because they tell us our smallest number, our biggest number, then the middle of the 2 halves, and then the middle of the entire data set.